We're going to dive into the fascinating world of game theory. Now, this isn't just about playing chess or poker. Nope. It's a really powerful way to understand the science behind our decisions, whether we're talking about rush hour traffic or even global politics. So, let's get right into it.
All right, let me start with a puzzle, one I bet you've thought about before. Why is it that when every single one of us makes what feels like the smartest choice for ourselves, we can all end up in a situation that's actually worse for everybody? It feels like a total paradox, right? Well, that's the exact question game theory was built to answer.
To really get what we're talking about, let's use a super familiar example. Just picture this. You're completely stuck, bumper to bumper, on the main highway. You're running late, you're getting frustrated, and then you remember. There's a back road that could get you around this entire mess.
So the rational thing to do is to peel off and take that back road. I mean, it's a no-brainer. And hey, if you're the only one who does it, you're a genius. You've just beaten the system. But what happens when every other driver has the exact same brilliant idea? Well, suddenly, that secret little back road is the new traffic jam, and maybe it's even worse than the one you just left. And that's the core of our problem. So this whole situation, where smart individual choices lead to a bad group result, we can call that the strategy paradox. And the field of study designed to unpack exactly this kind of problem, that's game theory.
So what is game theory, really? Well, the official definition is it's the study of strategic interaction among rational decision makers. Basically, it's a way of looking at situations where the outcome of your choice depends heavily on the choices other people make. You're not making decisions in a vacuum. It's all connected.
And just like any game you can think of, from chess to soccer to Monopoly, these strategic situations have a clear set of rules and pieces that we can actually break down and look at.
And what's really cool is that you can boil down almost any strategic situation to three core things. First up, you've got the players. Those are the decision makers. Second, you have their strategies. Those are all the possible moves they can make. And finally, you have the payoffs. That's the outcome, the reward or the consequence for each combination of choices. All right, so to really see these components in action, we're going to look at the most famous example in all of game theory, the prisoner's dilemma. It's a simple little story that does a brilliant job of showing this tension between what's best for you and what's best for the group. Okay, so here's the setup. Two partners in crime get arrested. The police put them in separate interrogation rooms. And this is key. They cannot communicate with each other. They have no idea what their partner is going to say. Then the prosecutors walk in and offer each of them the exact same deal. Okay, let's really break this down. Put yourself in prisoner A's shoes. You have to figure out what your partner, prisoner B, is going to do. Let's walk through it. Scenario 1, let's say prisoner B stays silent. He cooperates with you. Well, if you also stay silent, you both get a reduced sentence. Not bad. But if you betray him, you walk free. That's a way better outcome for you. Okay, now for scenario 2. What if prisoner B betrays you? Well, if you stay silent, you're looking at a severe sentence. But if you also betray him, you both just get a moderate sentence. So even in this case, you're better off betraying him.
And this right here reveals a key concept called the dominant strategy. Did you notice that? No matter what prisoner B did, whether he stayed silent or betrayed you, your best move was always to betray him. That's a dominant strategy, the choice that gives you the best personal outcome, regardless of what the other player does. And in this game, both prisoners have the exact same dominant strategy. Betray the other guy.
So if both players logically and rationally choose their dominant strategy, where does that leave them? Well, it leads to an outcome that's very stable, but definitely not a happy one.
This stable state has a name. It's called a Nash Equilibrium, named after the brilliant mathematician John Nash. It's a point in the game where no player can do better by unilaterally changing their strategy. I mean, think about it. Once they've both betrayed each other, they're stuck. If just one of them decided to switch their story and stay silent, they'd get a much, much worse sentence. They are locked into that mutual betrayal.
And this brings us to the most powerful and kind of mind-bending insight from game theory. A stable outcome is not necessarily the best outcome. The Nash Equilibrium, the logical result of the game, is for both prisoners to betray each other. But the optimal result for the group, that would have been for both of them to cooperate. The very logic of the game pushes them into a worse-off position.
Now, you might be thinking, okay, that's a neat little puzzle, but what does it have to do with the real world? Well, it turns out the logic of this dilemma is absolutely everywhere. Once you learn to see it, you start spotting it in business, politics, even in nature.
I mean, just think about it. In business, you have two companies that get locked into a price war, slashing prices until neither of them is making a good profit. In global politics, you have arms races, where two countries keep spending billions on weapons, even though they'd both be safer if they just agreed to disarm. It even shows up in things like the tragedy of the commons, where a shared resource, like a fishery, gets completely depleted because it's in everyone's individual interest to take as much as they can.
And this isn't some dusty old academic theory either. Today, game theory is literally the engine running some of the most advanced AI and analytics out there. It's how self-driving cars try to predict what other drivers will do, how cybersecurity systems anticipate attacks, and how smart electrical grids manage energy flow. They're all playing incredibly complex games, and game theory is what helps them pick the best next move.
So, the crucial takeaway here is this. Game theory doesn't just show us why we get stuck in these less-than-ideal situations, it gives us a map, a framework to actually understand the game we're all playing. And that leads us to the most important question of all. If we can understand the rules of the game, can we figure out a way to change them to create a better outcome for everyone?